Good morning.
Very good morning, students. Good morning, all of you. So let us start with the discussion. Last class we have studied about IUPAC nomenclature and a different rules has been given to you. Like the format of naming the organic compound according to IUPAC nomenclature is first comes the secondary prefix. Secondary prefix gives idea regarding the substituents, what type of substituents are present. Primary prefix gives idea regarding the whether the cyclic group is there or not. Root word gives idea regarding the number of carbon atoms, including the carbons of principal functional groups. Primary suffix gives idea regarding the type of bonding, like carbon-carbon single bond or double bond and triple bond. Secondary suffix will be giving idea about the type of principal functional group present. And we have to look at all these principal functional groups based on priority order, because there are a lot of cases where more than one organic compound or organic functional groups are present in the same organic compound. In the same compound, I can have a carboxylic acid group and alcoholic group. So we have to give the priority order. So which has to be given the highest priority, which has to be treated as a principal functional group. That is based on this order, right? Principal functional group. If the principal functional group is RCOH, RCOH is a principal functional group means we have to use the suffix as oic acid. Understand this point carefully. Principal functional group, if it is RCOH, the suffix is oic acid. You may ask a question, sir, if it is given the first priority, then always it has to be treated as suffix. Then why the prefix and special suffixes are given? Okay, this prefix and special suffixes, they are also used in special cases. We are going to look at those cases also, even though the carboxylic acid is given the first priority. Suffix is oic acid, prefix is carboxy, special suffix is carboxylic acid. RSO3H means sulfo. That means whenever we have COH and SO3H, first priority you have to give to COH, naming it as oic acid. And the second priority has to be given to SO3H group. If it is SO3H group is taken as a second priority or the substituent, in that case you have to use this as a sulfo, that is prefix. And whenever SO3H is the main functional group, then it is sulfonic acid. C double bond O, C double bond O. It has a suffix of oic anhydride, carboxylic anhydride. R C double bond R, it is alkoxy carbonyl or carbalkoxy. This is going to be the prefix and the suffix is going to be O8. Special suffix is carboxylate. Like that, we are going to define the prefix, suffix, and special suffix for all types of functional groups. RCOX. RCOX means you will be having this type RC double bond X. It will have a suffix of oil halide, prefix of halocarbonyl, special suffix of carbonyl halide. RC double bond NH2, RC double bond NH2. RC double bond NH2 is carbonyl amide, carboxamide. These are the prefix, suffix, and special suffix. RCN, CN is said to be nitrile whenever it is the main functional group. If it is a substituent, you have to take cyano. Special suffix is carbonitrile. RCHO, suffix is all, like it is an aldehyde group, all, and you have the prefixes oxo or formyl. So when oxo is used, when formyl is used, that we are going to look at based on examples. Special suffix is carbaldehyde. Whenever we have R, C double bond O, like R, C double bond O, R dash, like both sides have alkyl groups connected, it is said to be on, the suffix is said to be on, and the prefix is said to be oxo or keto, and there was no special suffix in this case. Like such molecules will not be having special suffixes. Is everything clear, students, so far? Yes or no?
Yes, sir.
Like these are the rules we have to follow. Okay, you may ask a question, sir, why it is so? I have not given the rule. IUPAC is a society. Yes or no? That will be deciding every change, whatever has to be done in chemistry. So ROH, suffix is ol, prefix hydroxy. RSH, suffix is thiol, prefix is mercapto. RNH2, suffix is amine, prefix is amino. Prefix is amino, suffix is going to be amine. So let us now look at different examples and different other molecules, like how to actually use the name and how we can assign IUPAC name to different sets of compounds. Like we have this CH3, CHOH, CH2, C double bond OH. All of you try to give the try to give the name for this particular compound. With the knowledge whatever you have already, we can simply say, like we have to select the parent carbon chain. We have to look for principal functional group. We have carboxylic acid group and OH. So principal functional group should be carboxylic acid group. It has to be given the highest priority. Substituent OH has to be taken as
hydroxybutyric acid.
yes or no. Numbering, how we have to give? So the rules of numbering we are going to discuss, but as the example comes, we can directly write here. The numbering has to be given in such a way such that the lowest number has to be given to the principal functional group. So 1, 2, 3, 4. 4 carbons are there. 4 carbons means what? Root word is but. Before root word, we have the primary prefix. Primary prefix means what?
Hydroxy.
Primary prefix means whether the compound is cyclic or not. It is not cyclic, so no primary prefix. So secondary prefix, substituents. What are the substituents? We have OH group, that is OH is taken as substituent, so it is 3-hydroxy. 3-hydroxy is the secondary prefix, and I'm not writing the primary prefix because there is no cyclic compound, and this is the root word but. And what type of carbon-carbon linkage is seen? Sorry,
Single bond.
carbon-carbon single bonds. So AN, yes or no? Whenever we have carbon-carbon single bond, you should write AN, and you have oic acid. After primary prefix, after primary suffix, you have to write the secondary suffix. Secondary suffix is the secondary suffix for the carboxylic acid is oic acid. And whenever you are writing the oic acid, you have to remove the E of AN because oic acid start with an vowel O. So if the principal functional group suffix starts with the vowel, then E you have to drop in the primary suffix, then you have to continue. Like you will be having 3-hydroxy, 1 butanoic acid. Butanoic acid. Okay, that will be the right name. So 3-hydroxy butane 1-oic acid or 3-hydroxy 1-butanoic acid, that is going to be your right name. We have followed the same logic. Secondary prefix, then primary prefix, then root word, then primary suffix, then secondary suffix. But there was no primary prefix, so we have eliminated it. Remaining all 4 we have mentioned carefully. Is that clear? Yes or no, students?
Yes,
Yes, sir.
Yes, right. Very simple example these are. Now let us start with some set of rules. So although we have seen the primary suffix, primary prefix, all those names, secondary suffixes, secondary prefixes, but there are some set of rules which you have to follow when you are going to select the parent carbon chain or while you are giving the numbering. selection of parent carbon chain PCC. So in that first rule, select the chain having maximum number of principal functional groups, multiple bonds, carbons and substituents. Understand this point carefully. We have to select the chain in such a way such that we have maximum number of principal functional group. First point is you have to select a chain which has maximum number of principal functional group, principal functional group that is given highest priority, then multiple bond, then multiple bonds, maximum number of multiple bonds should be there, and then carbon atoms, number of carbon atoms. If all these are same, then you have to look at substituents, maximum number of substituents. So on this order, so you have to select the principal functional group based on the order, like the maximum number of principal functional group should be there. Then like principal functional group is always one functional group. So you whatever the chain you are considering, in that chain only you should be getting the substituent functional groups also. And multiple bonds and number of carbon atoms and substituents, in this order you have to select. So this is your rule. So priority order, principal functional group greater, multiple bond, then number of carbon atoms, then number of substituents. What is the parent carbon chain here? Although all the 4 carbon atoms are simply connected in a long chain, so parent carbon will be directly this chain. Yes or no? Which has 4
Yes,
carbon
sir.
atoms. No issue in this case. Whatever the second example, what is the parent carbon chain? So 1, 2, 3, 4. You can select 1, 2, 3, 4. Again same. I can give, like I can select this chain, or I can select this chain, or I can select this chain. Yes or no? But I cannot select which chains. So we have carbon, 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 CC linkage. I cannot select this chain because only 3 carbon atoms are there in the parent carbon chain, where the maximum number possibility is 4 here. So that will be your principal parent carbon chain. Second, this compound, third compound. What is the parent carbon chain which has maximum number of carbon atoms? Because these are alkanes, there are no principal functional groups. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So can I select this chain which has 5 carbon atoms?
Yes.
Yes.
Yes, right. Next one, 1, 2, 3. Like select here the parent carbon chain. I have 1, 2, 3, 4, 5, 6. Can I select 6 carbons atom in the long chain?
No, sir.
Was functional group.
Functional group is there as well as double bond is there. So first functional group has to be given the priority, then multiple bonds. So we have to include a chain such, we have to select a chain which includes the functional group as well as the multiple bonds, even though it contains less number of carbon atoms, because the order is principal functional group greater priority, then multiple bonds, then the number of carbon atoms. So 1, 2, 3, 4, that will be a long chain which includes the functional group carbon as well as the C double bond C carbon. Okay. So this 1, 2, 3, 4, although we have only 4 carbon atoms, that is actually including the functional group as well as the multiple bonding. Now select here. Select the long chain here. Like if I select a chain like this, 1, 2, 3, 4, 5, 6, I'll be getting 6 carbons in this direction. 1, 2, 3, 4, 5. I cannot select this. 1, 2, 3, 4, 5, 6. I can select this one, this particular chain, one possibility. I have the molecule like this. I'll write different possibilities. C, C, C.
So we'll take the one with both methyls included.
Both methyls and.
So both methyls
So
included in that.
okay, I'll just give the different chains. You just try to figure out. This is first possibility, first long chain, because 6 carbons are there. 1, 2, 3, 4, 5. I cannot select this, but I can have also 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I cannot select that. 1, 2, 3, 4, 5, 6. I can select this one. This is chain 2. 1, 2, 3, 4, 5, 6. I can select this one. Chain 3. Out of 1, 2, 3, which one is right?
Third is
Third, sir.
What is the difference you are seeing here, students? Number
maximum
of substituents.
substituted
Maximum
greater
substituents.
So maximum number of substituents. Based on that, you can easily say this is third one is going to be the right parent carbon chain. So next compound is given in this fashion. Next compound, if you look at carefully, there are multiple bonds. Multiple bonds means that has to be given the highest priority. So there are two double bonds. So I'll be selecting a chain which includes both the double bonds. So 1, 2, 3, 4. That will be the parent carbon chain. So remaining all are going to be substituents, right? So this is the rule. If a carbon containing principal functional group is present, then its carbon is included in the parent carbon chain. This is the point. Like whenever I have a carboxylic acid, for example, then that carbon is also included in the parent carbon chain. You should count that also. Like we have this type of molecule. What is the name of this particular molecule? 1, 2, 3, 4. Yes or no? What is the name of this molecule? Because we have C double bond OH, you have to include this particular carbon in the parent carbon chain. You have to include the double bond also. So this is going to be your principal parent carbon chain, and the COH is the principal functional group. So first, second, third, fourth, this is the priority order. First, second, third, fourth, that will be the priority order, because the lowest number you have to give obviously to the principal functional group. So first you have to write the secondary suffix, secondary prefix, that is substituents. Where are substituent present? Second and third positions, what are they? Methyl substituents. 2, 3 dimethyl. 2, 3 dimethyl. Then we have what? 1, 2, 3, 4. 2 on the second and third positions we have dimethyl. That is your secondary prefix. After that we have primary prefix. There is no cyclic compound, so no primary prefix. So plus, how many carbon atoms in the long chain?
4.
That is parent carbon chain. So bute. And what type of carbon-carbon linkage is there? Carbon-carbon double bond is there. So you have to write in. And where do you have the what is the principal functional group? That is oic acid. And we on which position it is there? First position. So 1 oic acid. And oic acid starts with an OL. So whenever the secondary suffix starts with an OL, we have to remove the E of the primary suffix. So the ultimate name will be 2, 3 dimethyl
Butanoic
1 butenoic acid, right? Yes, students. So that is how we have to give the name, and this includes, actually we have to include the carbon atom of the parent carbon chain or principal functional group also. The carbon atom should be included in the parent carbon chain if the principal functional groups contains the carbon. This compound also you can name in the same way. Yes or no? What is the principal functional group or parent carbon chain? You select first. Parent carbon chain. Obviously the C double bond C is there. I have to include this. I cannot take 1, 2, 3, 4, 5, 6 that has a long chain. I have to include this and have to select in this manner. That is how we have to select the parent carbon chain, and then try to give the numbering and name it. Right. So now comes the question of numbering, like which has to be given the lowest priority, which has to give the highest priority, because we have selected the parent carbon chain. The next set of rules is numbering. How to give numbering in parent carbon chain? Yeah, this is what I'm talking about. Numbering in selected parent carbon chain. Selected parent carbon chain is numbered from the terminal, which gives lowest possible number to the principal functional group or multiple bond or substituents. The lowest number has to be given to principal functional group first, then the multiple bond, then the substituent. And order is obviously principal functional group greater, then multiple bond and substituent. If a carbon containing principal functional group is present at the terminal, the numbering starts from that carbon of the principal functional group. Like if you have a carboxylic acid group, numbering always starts from the carbon of C double bond OH, because it's the terminal functional group. You cannot have carboxylic acid in the middle. You cannot have C double bond OH in the middle. Why? Because C double bond OH, this carbon already included in 3 bonds. So the only one bond you can include further. You cannot have 2 bonds on 2 sides. That means C double bond OH is a terminal functional group. It will always be present at one of the end. It cannot be in the middle. If carbon containing principal functional group is present at terminal, then numbering starts from that carbon of the principal functional group. Like you give the example CH3, CH2, CH2, COH. You have to give numbering from the carbon of C double bond OH. So that is a parent carbon chain, and that will be a numbering. The first number has to be given to the carbon which contains C double bond OH. CH2 double bond CH, CH2, C triple bond N. Yes or no? So you have C double bond, multiple bond is there. Cn is the principal functional group. You have to give numbering from the multiple bond or from the principal functional group. principal functional group is given the highest priority. So you have to give numbering always from the principal functional group. So 1, 2, 3, 4. That is the correct number. Yes or no? That is the parent carbon chain. And if the carbon of principal functional group, if the principal functional group contains carbon, that has to be included in the parent carbon chain. So from that only you have to give the numbering. So 1, 2, 3, 4. That is the correct order of giving numbering. Is that clear, everyone?
Yes.
Yes, sir.
Yes, right. Very good. If the principal functional group is not carbon containing, then numbering starts from that terminal, which gives lowest number to carbon to which a principal functional group is attached, not necessarily 1. If the principal functional group, if the principal yes, if the principal functional group is not carbon containing, then numbering starts from that terminal, which gives lowest number to the carbon to which a principal functional group is attached. That is not necessarily 1. So understand this scenario. Like we have CH2 double bond CH, CH2, CHOH, CH3. So here how to give the numbering, students? CH2 double bond CH, CH2, CHOH, CH3. Which is the functional group here? Functional group should be given the high priority. Then you have to give the priority to the multiple bonding. So you have to give numbering. 2 ways are there. So 1, 2, 3, 4, 5. Other way is 1, 2, 3, 4, 5. So which way is the correct?
Again one. From right.
Like OH group should be having what numbering? OH group.
No.
OH group should be having the second numbering. So that will be the correct way. So you have to select the carbon-carbon parent carbon chain, which includes maximum number of carbon atoms. Here all are in the straight chain only, not an issue. And you have to give numbering in such a way such that OH get the lowest priority number. So 2 should be given to OH, 1, 2, 3, 4, 5. That is how you have to select. And what will be the name of this particular compound? 1, 2, 3, 4, 5. 5 means like on the second position, you have OH, but it is not a substituent, it is a principal functional group. Is there any substituent in this compound? No substituent. Is there any primary prefix? No cyclic compound, no substituent. So directly we have root word. Root word is 1, 2, 3, 4, 5, pent. Carbon-carbon linkage, if you look at double bond is there, so in. And on which position you have the principal functional group? On the second position. So 2, what is the principal functional group? Suffix? 2 ol. But where is the scene present? The in is actually present in fourth position. Yes or no? 4 in. So what will be the name? Pent 4 in 2 ol. And I have replaced E of the in, the last E, because ol starts, the OH secondary suffix ol starts with an OLO. Whenever it starts with an OLO, you have to replace E. So pent 4 in 2 ol, that is the name. So what about the second compound? Try to name this compound, all of you. Name this. These are the direct questions. Okay. So that is how questions can be asked. They can be giving different molecules to you. You have to name it. 1, 2, 3, 4, 5, and 2 substituents are there.
5-chloropentenamine, 3-pentenamine.
Yes. So whether you can give numbering in this fashion 1, 2, 3, 4, 5. You can also give numbering in this fashion 1, 2, 3, 4, 5. You are getting what? The same third position is getting to the amine. So which number you have to take priority? So the numbering where the lowest priority or lowest number is given to C double bond system. And in this system, you have the secondary suffix. Secondary suffix is just for NH2, it is amine, and Cl is the substituent. So substituent chlorine is present in the fifth carbon. So 5-chloro, and it is pent because 5 carbons in the parent carbon chain, and it is in where it is present.
Second compound.
Second carbon or first carbon?
First carbon.
First.
10 to 1 in, and what you can say 3 amine. And if you look logically, do we need to place 1 in, or we don't need to place 1 in? Check it out once.
We don't need to place.
No, sir.
We don't need to place, because if I have a double bond here, yes or no? In that case, the carbon will also already involved in 4 bonds, so NH2 cannot be there. If I have a double bond here, then also NH2 cannot be there, because carbon already involved in 4 bonds. If I have a double bond here, then the chlorine cannot be 5 chloro, it will be 1 chloro. So as I said, 5 chloro, this is the only possibility, so you don't need to place. If you place also, not an issue. So 5 chloro pent 1 in 3 amine, that is going to be the correct name of this particular compound. CH3, CHOH, CH2, CH2, NH2. Try to name this, all of you. OH and NH2. Now we have two functional groups, OH and NH2, which has to be taken as the highest priority. Highest priority is given to OH. So 1, 2, 3, 4. On the fourth position, you have NH2. Whenever NH2 is taken as substituent, it is called as amino. So 4 amino, butan 2-ol. Yes or no? On the fourth position, you have amino group. No other substituents. 4 amino, butan, because carbon single bonds are there. 2-ol. 4 amino, butan 2-ol. Everyone got this or not? Simple cases.
Yes, sir.
Yes,
Right?
sir.
Whenever you have a principal functional group, multiple bond and substituents, principal functional group is given the highest priority, then multiple bond, then substituent. That is the order of giving numbering. That is the preference order for giving the lowest number. Now, if the principal functional group is there, multiple bond is there, then you can go with the order. But if there are more than one substituents are more. If more than one substituent is attached to the parent chain, the chain is numbered in a direction that produces the lowest set of locands. Understand this rule carefully. Here what we are saying, if more than one substituent is attached to the parent chain, for the parent carbon chain, if more than one substituents are attached at different positions, then you can use all possible numbers. The numbering where the lowest set of locands is obtained, that is going to be the correct numbering. So let us understand that same with the example. So we have CH3, CH2, CHBr, CH2, C, Cl, CH3. Bromine is a substituent, chlorines are also substituents. They are not the principal functional groups. So I can use numbering in this way: 1, 2, 3, 4, 5, 6. I can also use numbering in this way: 1, 2, 3, 4, 5, 6. If I use numbering in the first way, what are the sets I am getting? 1, 2, 3. On the third position, I have bromine. On the fifth position, I have 2 chlorines. So 3, 5, 5. If I give numbering in this fashion, 1, 2, 3, 4, 5, 6. On the 2, 2, I have 2 chlorines, 2, 2, on the fourth position, I have bromine. So these are the possible set of locands or not? Yes or no? Locant positions. Possible locands. Yes or no? Lowest set of locands you should select. So first you have to look at only the first point of difference. That means here you have 3, 5, 5. Here you have 2, 2, 4. 3 and 2. Here itself you have the difference or not? 3 and 2. This is the first point of difference among 3 and 2. Which is smaller?
2,
2 is smaller, so you have to go with this rule. 2, 2, 4. That is the correct order. So you have to give numbering in such a way such that 2, 2, 4 is assigned. So this is going to be the correct numbering, and the name is going to be 4-bromo. What is the name?
4-bromo
4-bromo
2-dichlorohexane.
2,
2,
2
dichloro.
hexane. Very good. Yes or no? 4-bromo 2, 2 dichlorohexane. That is going to be the correct name for this particular compound, because there is a difference in the lowest set of locands, and you have to select that particular set of locands where you can see the lowest number for the first point of difference. Understand this carefully. Like in case I have a molecule where I am getting some 2, 3, 8 and I am getting 2, 4, 5. You should not see the difference. Like 2 and 2, are they different numbers or same numbers? That is not the first point of difference. So these are same. 3 and 4. 3 and 4. Yes, it is a difference. First point of difference is this one. 3 and 4, which is smaller? 3 is smaller. So this is the correct order. You don't need to say that among 3 and 4, 1 is the difference. Among 8 and 5, 3 is the difference. So this is going to be the, like if you look at the difference amount, 8 and 5 differ by 3 units. 3 and 4 differ by only 1 unit. You should not look at that. The first point of difference has to be taken into account. Okay. The lowest locant rule applies, and we have to look at first point of difference. We have to look at first point of difference, right? So this name is going to be 4-bromo 2,2 dichlorohexane. That's what I have already told you. Try to name this compound, students. If you remember, what is the common name for this? I have given an exception compound.
Neooctane.
Isooctane. Yes or no? We have said an exception. Iso will not be used if we have any other substituents, but this is an exception case we have told you. This is nothing but your isooctane. Very good. And try to give the numbering. Numbering I can give. Longest chain I have to select 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Anywhere I am getting 5 carbons only. So parent carbon chain will be that chain where we have maximum number of substituents. I will be selecting this chain. Now I have to give the numbering. So I can give numbering like this: 1, 2, 3, 4, 5. I can also give numbering in the other direction: 1, 2, 3, 4, 5. If I give in the first fashion, I'm getting 2, 2, 4. In the second fashion, if I try to give, I'll get 2, 4, 4. 2 and 2, they are same, not first point of difference. 2 and 4 is the first point of difference. So 2 is smaller, so I have to go with this number. Yes or no? So 2, 2, 4, that is the correct numbering, not 2, 4, 4. So 2, 2, 4 trimethyl pentane. That is the name. Yes or no? All the three substances are methyl groups. 2, 2, 4 trimethyl pentane. That is going to the correct IUPAC name. Right? Very good. Try to name this compound. CH3, CH double bond CH, CH2, C triple bond CH.
Hex 2 in 5-ine.
Hex 2 in 5-ine. So generally, you know, which is more priority when compared to double and triple bonds?
Triple bond.
Triple bond or double bond?
Double bond.
Double bond.
Double bond is given the highest priority, but when compared to double bond and triple bond, the lowest locant rule is highest priority. Okay, 1, 2, 3, 4, 5. So give numbering in this fashion: 1, 2, 3, 4, 5, 6. You can also give numbering in the other direction: 1, 2, 3, 4, 5, 6. You are getting, if you try to give numbering in this fashion: 1, 2, 3, 4, 5, 6, 2, 5, you will be getting the priority. 2, 5. If you try to give the numbering in the other way, 1, 2, 3, 4. 1, 4, you are getting the priority. Among 2 and 1, which is the lowest? 1 is the lowest. So this should be considered, or the other should be considered.
So 1, 4.
1, 4 should be considered or not?
Yes.
Yes or no? So if you look at this particular compound, you should give it 1, 4 as the highest priority. Why? 1, 4 as the highest priority. Why? Because the lowest locant rule. Lowest locant rule is given high priority. So hex 4 in 1, 9. Next compound, CH2 double bond CH, CH2 C triple bond C, CH3. Again, based on lowest locant rule, if you try to give numbering, obviously you have to give the first number to the C double bond system. 1, 2, 3, 4, 5, 6, and you have to write hex 1 in 4-ine, because on the first you are getting in, and you have to write always ine at the last. Is that clear, students? So these are different simplest compounds only. So let us try to name. If we get same set of locands, then alphabetical order is considered. Like if you are having same set of locands, like 2 5 2 5 3 5 3 5 1 2 1 2. If that is like 3 4 3 4. If that is a possibility, if you try to give the positions, in that case you have to follow the alphabetical order, which is having the smallest alphabet that will be given the highest priority. Like CH3, CHCl, CH2, CHBr, CH3. If I give numbering in this direction, 1 2 3 4 5. 1 2 3 4 5. I'll be getting second number and fourth number 2 comma 4. I'm getting the substituents. If I give other direction also, I'll get again 2 comma 4. But here we have bromo on the second, whereas I have chloro on the fourth. So B comes first. B comes before C. So I can say 2 bromo 4 chloro pentane. This is the correct order because based on alphabetical order we can say 2 bromo 4 chloro pentane because we are just following the alphabetical order. Try to give numbering, students, in different other compounds. CH3, CH2, CH, C2H5, CH2, CH, CH3, CH2, CH3. Try to give name all of you. One, two, three, four, five, six, seven. Here we have C2H5. Then you have to imagine like two carbons are there. 1, 2, 3, 4, 5, 6, 7. Both the carbons are chain. Because if I consider this chain, again we have ethyl substituents. If I consider that chain also, again we have ethyl substituents. Both are same, so I don't need to worry with the long chain. If I give numbering 1, 2, 3, 4, 5. So I'm getting 3 and 5. If I give in this fashion 1, 2, 3, 4, 5. So 3, 5, 3, 5 are the sets. So we should be given the correct order. On the third position, you have ethyl here.
3 5.
Yes or no? On the fifth position, I have methyl here. So 3 should be given to the ethyl because based on the alphabetical order. So you can say 3 ethyl, 5 methyl heptane. 3 ethyl, 5 methyl heptane. Now try to give the numbering CH triple bond C, CH2, CH double bond CH2. I can give numbering in this fashion 1, 2, 3, 4, 5. I can also give numbering in this fashion 1, 2, 3, 4, 5. So we all know that double bond should be given highest priority when compared to triple bond, but that is based on again alphabetical order only. Because if you look at the first position, I'm going to write in, 1 in. I'm going to have substitutions 1, 4, here also 1, 4. In this way also I'm getting 1, 4. In the other way also I'm getting 1, 4. But here double bond means in, triple bond means in. So E and Y, if you try to compare which comes first, E comes first. So you have to give first priority to the double bond. So pent 1, 2, 3, 4, 5, 5 carbons. So pent on the first position you have in. So pent 1 in, 4 in. Pent 1 in, 4 in. Yes or no? Pent 1 in, 4 in. Everyone clear with these examples or not?
Yes.
Yes, sir.
Yes, right. So now we can look at some of the cases like radicals. How to name radicals in the IUPAC system? Like CH3 means you can simply say methyl radical, ethyl. So same names you can use in the IUPAC system also. Like whenever we have a complex radicals, there the names are going to be slightly different. Whenever we have a complex radicals, there the names are going to be slightly different. For simple names, for CH3 it is methyl only. For CH2 CH3 ethyl, CH2 CH3 CH3 propyl or N-propyl, CH2 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 CH3 butyl or N-butyl. CH double bond CH2, what should the name you use? Vinyl or ethynyl. CH2 CH double bond CH2, prop 2 enyl or allyl. C triple bond CH, what is the name you are going to use? Ethynyl. CH2 C triple bond CH, prop 2 enol. Inyl, okay, not all. Prop 2 inyl. So for this, the complex radicals, these are all simple radicals only. So directly, like whatever the radicals you have, they will be having the simple names only. So no complexity involved. As of now, consider this case. It is called as
Phenyl.
Phenyl.
phenyl ring, right? Very good. Consider this case. Next case, CCH3, CH3, CH3.
Third butyl.
Tertiary butyl. Yes or no? And you can also name this as 1,1 dimethyl ethyl. Why I am naming this? Like we have a long chain R to which this substituent is there. C, CH3, CH3, CH3. This is the longest chain. Somewhere we have this particular substituents. If I have just CH2, CH3, what is it called as? It is said to be ethyl. But on the, like, it is ethyl 1 and 2. I can use numbering in the substituent also. So 1 and 2, that is the ethyl positions. On the first carbon of ethyl, both the hydrogens were actually replaced by methyl groups. So 1,1 dimethyl ethyl I can write. 1,1 dimethyl ethyl. I can write like this or not? The same substituents. Tertiary butyl is a complex substituents where I can write 1,1 dimethyl ethyl as its correct name. CH3, CH3. Now what I am going to write? Generally it is called as isopropyl. Yes or no? CH3, CH3. It is said to be isopropyl. Its name can be what, students? In the complex radical, it is a complex radical.
One
If I-
methyl ethyl.
One methyl ethyl, because if I have CH2, CH3, it is simply ethyl. But on the first carbon of CH2, that is first carbon of ethyl, I have a CH3 substituent. So on the first position, I have methyl, one methyl ethyl. Isopropyl or one methyl ethyl. Next, this one, you try to answer. It is said to be what type of simple radical? Like how to name this in the common system? CH, CH3, CH2, CH3. Like I have alkyl group, somewhere I have CH, CH2, CH3, CH3. How to name this?
Isopropyl.
Isobutyl, we are going to use isobutyl. Iso is only used whenever we have CH, CH3, CH3 system. That system is not there here. CH3 is not there, so it is a secondary butyl. Yes or no? Whenever we have this kind of scenario, then only we use isopropyl. If you have CH3, CH2, CH3, it is like a secondary butyl. And if you go with the naming, CH2, CH2, CH3 is propyl, but on the first position you have methyl substituents. So one methyl propyl. What about this? Here we have CH, like here we have CH, CH3, CH3. In the common naming system, we can call this as isobutyl, because 4 carbons are there where the iso group is present. So isobutyl. And what is going to be the complex name for this? 1, 2, 3. It is supposed to be propyl, but on the second position you have methyl substituents. So 2 methyl propyl. Isobutyl is a common system, or you can also name it as 2 methyl propyl. Is that clear or not?
Yes.
Yes, right. Next, if same simple substituent is present more than once, then we use the prefixes like di, tri, tetra. They have to be used before the prefix. And if same complex substituent is present more than once, that then you are going to use bis, tis, tetrakis. If you remember, the same we are going to use in the while naming complex compounds also. Like whenever we have a bidentate ligand, more than one bidentate ligands are there, then you are going to use bis, tis, tetrakis. If you have a simple ligands, we use di, tri, tetra. Yes or no? So di, tri, tetra are used for 2, 3, 4 number of substituents. And if you have more than one type of complex substituents, then you use bis, tis, tetrakis, etc. Di, tri, etc. of simple substituents are not considered in alphabetical order, but first letter of complex substituent is considered in alphabetical order. Understand this. If you write a di, tri, etc. for simple substituents, you should not consider that for alphabetical order. But in case if it's a complex substituent, then you can consider. Or first letter of complex substituent is always considered for alphabetical order. If it is a simple substituent, you should not consider G and T to compare the alphabetical order. But if it's a complex substituent, you can compare. Iso, neo, cyclo are considered in alphabetical order. Iso, neo, cyclo. Whenever you are writing iso, neo, and cyclo, they have to be considered in alphabetical order. But secondary, tertiary, so these are not considered for alphabetical order. These are not considered in the alphabetical order. You will get clarity only when you try to look at examples. Try to solve this example. What is the name of this particular compound? It is the simplest compound. I can give numbering from this side 1, 2, 3, 4, 5, 6. Other side also I can give numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Anywhere I'm getting 6 carbons, so it is going to be hexane because no other functional group and no double bonding. If you try to give numbering also 1, 2, 3, 4, 5. So 2 and 5 positions they are substituted. In the other way also 2 and 5. So 2 comma 2 comma 5 comma 5 tetramethyl hexane. Yes or no? 2 comma 2 comma 5 comma 5 tetramethyl hexane. That is going to be the correct name because we have just looked at the example where we are going to use tetra because 4 substituents are there. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Try to give this, solve this question. CH2 double bond CH, CH, CH double bond CH2, CH double bond CH2. So we have to consider the parent carbon chain in such a way such that you include maximum number of carbon atoms as well as maximum number of principal functional groups and multiple bonds. There are no principal functional groups here, but we have multiple bonds. So I can include only 2 multiple bonds if you look carefully. Either I can select the chain like this 1, 2, 3, 4, 5, or this chain. In both the ways, the same chains we are looking at. So we can include only 2 functional groups, so that is 2 multiple bonds, 2 double bonds, not the third one. So I can select a chain in this fashion, and in both the ways you can give numbering 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. I'm getting the same position, so it's going to be same if you give numbering from either sides. And 1, 2, 3, 4, 5. And what do we have here, students? On the third position, what do we have? Third position, CH double bond CH2, what is said to be vinyl or not? So 3 vinyl pent 1 comma 4 diene. 3 vinyl pent 1 comma 4 diene. That is going to be the correct IUPAC name. 3 vinyl. You can write penta 1 comma 4 diene, or you can write pent 1 comma 4 diene. Or you can write instead of vinyl, you can also write ethinyl, 3 ethinyl. What is the second name? CH3 C double bond C, CH3. Can I select the parent carbon chain like this and try to write the numbering like 2 comma 3 diethyl butene?
Yes, sir.
Yes. Is that
Sir,
correct?
we
The
can
selection of
also select,
No, sir.
a methyl group and methyl is considered substituent.
methyl as consider substituents. So I cannot consider this one because 4 carbons are on this. If I consider the long chain in this way, I'll be getting only 4 carbons. So wrong selection of PCC. You have to look carefully at the substituents. C2H plus C2H means 2 carbons are there in this side. So you have to collect this as the long chain, and you can say numbering you can give from either sides, both are same because symmetrical compound. And third and fourth positions you have 2 methyl groups, 3 comma 4 dimethyl hexathreene. That is going to be the correct name. 3 comma 4 dimethyl hexathreene. That is going to be the correct IUPAC name of this particular compound. Is that clear, students?
Yes, sir.
Yes, sir.
Yes, right. You try to give next name of the next compound. CH3 CH2 CH C2H5 CH CH CH3 CH3 CH C CH3 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 CH2 CH2 CH3. First select the long chain 1 2 3 4 5 6 7 8. I'm getting long chain in that way. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So that is not going to be a long chain because it has less number of carbons. 1 2 3 4 5 6 7, not long chain. 1 2 3 4 5 6 7 8. So both the chains are same, because if I consider in this fashion also I'm getting ethyl substituents. If I consider in this fashion also I'm getting ethyl substituents at the same carbons. So what is my chain going to be? And I have to follow the lowest locant rule. So I have to always give numbering in this direction. I cannot go with the other chain. If I start from numbering here 1 2 3 4, on the fourth I'm going to have a position. But if I give in this number in this direction, on the third carbon only I'm getting the substitution. So 1, 2, 3, 4, 5, 6, 7, 8. This is the correct numbering and the correct parent carbon chain. Now try to write down the compounds. On the third position you have ethyl. What are there? On the third you have ethyl. On the fourth you have what? On the fourth you have what?
Isopropyl.
Isopropyl. And on the fifth you have what? Tertiary.
Tertiary butyl.
Tertiary butyl. Do we need to consider tertiary, secondary while looking at alphabetical order?
No,
We should
sir.
not consider secondary or tertiary. But we can consider isoneocyclo. I can consider, ethyl E consider, and tertiary I should not consider, butyl B I should consider. So I can write what is the correct name? 5 tertiary butyl. Then because alphabetical order I have to follow. After B I am getting E, so 3 ethyl. After that I can write 4 isopropyl.
Propyl.
So these are all the secondary prefixes done. Primary prefixes, there is no cyclo compound, and root word is 8 carbons. So oct, carbon carbon single bond linkage is there, oct plus N, and no functional group, so octane. So 5 tertiary butyl. So I have to consider B, E, and I. Yes or no? So this is how you can name it, and you can also use the complex substituents. Like I can write CCH3, CH3, CH3. This has 5 of 1 comma 1 dimethyl ethyl, because tertiary butyl you can name as 1 comma 1 dimethyl ethyl, and 3 ethyl, and 4 isopropyl. How you can write? 4 of 1 methyl ethyl, 1 methyl ethyl. Yes or no? Octane. Now whenever you are writing dimethyl in the complex substituents, you have to consider D or not? If it is a simple substituent, you should not consider D. In the complex substituent, you have to consider D or not?
Yes.
If you do not consider D, which comes first? 3 ethyl has to be coming first. But if it is, if this di is in the complex substituent, you can consider G. Understand? If we have diethyl, then you should not consider G while comparing alphabetical order. But you have to consider D here because this D is in the complex substituent. This dimethyl ethyl is in the complex substituent, not the simple one. So D, E, and M. That means whether you write the name using the simple common naming systems, like radicals are named in the common names or in the IUPAC naming, both should be same order. 5 of 1 comma 1 dimethyl ethyl, 3 ethyl, 4 of 1 methyl ethyl octane, that is the name, or 5 tertiary butyl, 3 ethyl, 4 isopropyl octane, that should be the name. Everyone got it?
Yes, sir.
Yeah, 5 tertiary butyl, 3 ethyl, 4 isopropyl octane. We are getting same. 5 of 1 comma 1 dimethyl. So you have to include D because if it is a complex substituent, 1 comma 1 dimethyl, 3 ethyl, or 1 methyl ethyl octane. Right. Try to name this compound. CH2 double bond C, CH, CH3, CH3. Like I have to include all the double bonds, right? So if I want to include both the double bonds, I can only select this chain. Is there any other possible chain? If I consider this chain 1, 2, 3, 4, 5, 6, I am not including the carbons which are possessing the double bonds. So only this chain 1, 2, 3, 4 carbons in that chain. 1, 2, 3, 4 carbons. So what I'm going to get, students? 1, 2, 3, 4, and the second and third positions. What do we have? Second and third position, same substituents. What are the substituents? Isopropyl. So 2 comma 3 diisopropyl bute,
Mute.
1 comma 3 diene, right?
Yes, sir.
2 comma 3 diisopropyl buta, 1 comma 3 diene, or you can also use bis whenever it is a complex substance. So 2 comma 3 bis, 1 methyl ethyl, because this isopropyl is nothing but 1 methyl ethyl buta, 1 comma 3 diene. You can also write bute here You don't need to write only always buta. You can write but also, not an issue. Right. So then let us now look at the different carboxylic different functional groups, starting from carboxylic acids and all other. Like we have given suffixes, special suffixes and prefixes of all the functional group earlier in the table also. But again, we look at some basic example of each functional group and then go on with the final examples. Suffix oic acid, special suffix carboxylic acid, prefix is carboxy. Suffix is oic acid, special suffix is carboxylic acid, prefix is carboxy. CH3 C double bond OH. What is this called as? 1,2. It is said to be acetic acid because two carbons are there in the common system. This is a carbon containing functional group except ketone, that is going to be radical independent. It is a radical independent functional group. So if we have two carbons, we should use acid. So acetic acid. Now if you look carefully, in the IUPAC system we have two carbons, means it should be eth. So ethanoic acid. Carbon single bond is there. So ethanoic acid. Try to name it here. CH3 CH double bond CH COH. What is the name of this compound in the common system as well as in the IUPAC system? In the common system, how we have named this? Simple molecules I have given the names in the common system also, if you remember. Like what is this carbon? Yeah, very good. Crotanoic acid. Yes or no? CH3 CH double bond CH. This carbon is the carbon containing functional group, means then you use crotanoic acid if it is COH. And if you look carefully, IUPAC system, so numbering you have to give 1, 2, 3, 4. Always principal functional group has to be taken to priority. So it is nothing but but, no substituents, no cyclo. So but 2-enoic acid. But 2-enoic acid or protonic acid. What is the name of this in the common system? Oxalic acid. Yes or no? And in the IUPAC system, it will be having a name like ethane, like 1,2 ethane 1,2 dioic acid or ethane dioic acid. Ethane 1,2 dioic acid or oxalic acid is the common name, right? So that is for carboxylic acid, simplest names. Acid halides, RC double bond X. So suffix is going to be oil halide. Special suffix carbonyl halide. Prefix is halocarbonyl or haloformate. You try to give numbering. What is the name of this compound? CH3 C double bond Cl. All of you.
Acetyl chloride.
You have to give the naming, students. Acetyl, do we need to use? Fatima, are we supposed to use acetyl in IUPAC systems?
No.
So what is the name of this compound? CH3 C double bond Cl.
Ethanol chloride.
Suffix is oil chloride. Two carbons are there. So ethanoyl chloride. Ethanoyl chloride. CHC. Try to name this, all of you. Try to name this 1, 2, 3, 4. C double bond system is also there. Try to give the name of this compound. Like 1, 2, 3, 4. This is the naming, numbering. But, but 2-ene, but 4 carbons. On the second carbon, you have like double bond, so 2-ene, but 2-ene. What is the suffix? Oil halide, oil bromide, or you can say but 2-butanoyl bromide or but 2-enoyl bromide. But 2-enoyl bromide or 2-butanoyl bromide. That is going to be the correct name, right? Acid amide. Try to name this compound. CH3 C double bond NH2. You have to give the names. Okay, the more you interact, the more you are going to learn.
Ethanamide.
Ethanamide. Those two carbons, and you have the name suffix is going to be amide. So ethanamide. CH3 CH2 C double bond NH2.
Propanamide.
Propanamide. Very good. 1, 2, 3. So propanamide. Propanamide. Aldehydes. CH2 double bond CH-CHO. Try to name this, all of you. CH2 double bond. Look at the scale.
Prop 1 into
Probe 1 in or probe 2 in?
probe 2 in?
Because on the numbering has to be given from the, like, principal functional group has to be given the highest priority. So lowest possible number should be given to CHO. So 1, 2, 3, that is the correct number. And probe 2 in all. Or you can say 2 probe in all or probe 2 in all. Both are same. And in the common system, it is said to be acryl aldehyde because this carbon is said to be the acryl carbon. What is the name of this? CHO, CH double bond, CH, CH3. Simple compounds only. Every functional group, simple compounds.
Bute 2 in 1 all.
2 butene.
Whenever we have aldehyde, you don't need to represent 1 all, because if C double bond is in middle, then it should be ketone. Yes or no? Yeah, bute 2 in all or 2 butanol or crotonaldehyde. Why I am not representing 1 all? Because if it is aldehyde, it has to be the terminal functional group. If it is in the middle, it will be a ketonic group. Try to name this compound. Ketone, suffix on, prefix ox or keto. CH3, C double bond or CH3. What is the name of this compound?
Propanol.
Propanone. Do I need to write 2 on?
No, sir.
Because
No,
if
sir.
the C double bond is on the first or third carbons, then obviously it is going to be aldehyde. It is not going to be ketone. So propanone is sufficient. So propanone, common name is acetone. CH3, C double bond or CH, CH3, CH3. What is the name of this? I can use numbering in this fashion 1, 2, 3, 4, or I can use numbering in this fashion 1, 2, 3, 4. Which is correct numbering? Lowest number should be given to the functional group. So obviously 1, 2, 3, 4. That will be the correct numbering, correct set of numbers. And on the third position you have methyl. So 3-methyl butane 2 on I have to mention or don't need to mention. If I cannot have on if it is first carbon or fourth carbon or on the substituent third carbon. So I don't need to mention again because that is the only carbon where I can have on. If you want, you can write also, not an issue. 3-methyl butane 2 on or 3-methyl butanone. That is also same. 3-methyl butanone, right? Cyanide. Try to give numbering in cyanide. CH3, C triple bond N. What is the name?
Ethanamide.
Ethanamide. Ethane nitrile. CH3, C triple bond N is ethane nitrile. CH3, CH2, CH2, C triple bond N. What is it?
Propane
Here you are including the carbon of
butane
Here
nitrile.
also you should include the carbon. So butane nitrile, right? Alcoholic groups. CH3OH. What is this called as?
Methanol.
Methanol. CH3CH2OH. Ethanol. We all know that. Simple names. CH3CH2. C double bond CH2 CH2OH. What is the name here going to be? We have to include the carbon which contain OH group as well as the C double bond system. So I have to include this as my parent carbon chain and I have to give numbering in this fashion so that I will be getting the lowest possible number of OH. So 1, 2, 3 on the second position I have ethyl. So what is the name? What is the name?
2-ethyl propane 2-in-1-ol.
Yeah, 2-ethyl prop 2-in-1-ol. Right? Very good. 2-ethyl prop 2-in-1-ol. Right? Thioalcohol students. Thioalcohols, how to give name? CH3, CH, SH, CH3. For thioalcohol, how to give the name? Thioalcohol itself is the secondary suffix going to be CH3, CH, SH, CH3. So you can have, what is this? It is nothing but propane. Propane. Where is the SH group? Second position. So propane to thioalcohol. Propane to thioalcohol. I have to mention the numbering also because I can also have the SH group on the first position. So propane to thioalcohol, that is going to the correct name. Right? CH2. If you have this type of functional group like CH3, CH, CH2, CH double bond, SH2, I have to give numbering in such a way such that the carbon containing SH group that should be getting the lowest possible number, because functional group is given the more priority when compared to multiple bond. So 1, 2, 3, 4, 5. So what is the name of this compound going to be? I have pentofluorine to thioalcohol. Pentofluorine to thioalcohol, that is going to be the name of this particular compound which is given. Right. Try to name this compound. I have already given the numbering because SO3H is the highest priority group. So you have to proceed in such a way such that lowest number is going to be getting to SO3H carbon. The carbon connected to SO3H. 1, 2, 3, 4. 4 carbon is bute. On the third carbon you have chloro. So 3 chloro, butane, 3 chloro, butane, and SO3H is now principal functional group. So you can use 2 sulfonic acid. 3 chloro, butane, 2 sulfonic acid. That is going to be the correct name for this particular compound. Right? We have the same name, right? 3 chloro, butane, 2 sulfonic acid. That is because just we have to follow the order. Secondary prefix, primary prefix, root word, primary suffix, secondary suffix. Amines suffix is amine, prefix is amino. Try to name this compound NH2, CH2, CH2, and CH3. NH2, CH2, CH2, CH2. Like propane,
Propanamide.
propanamine 1. You have to give 1 numbering because NH2 can be also on the second position. Propan 1 amine. Here, obviously, you have to give numbering in this fashion 1, 2, 3, 4, 5. So that if you give the numbering in the other way, also you are getting third position to NH2. So it doesn't matter. So you have to give the numbering based on the C double bond C system because NH2 is third position in either ways. So what is the name going to be? Pent-1-ene 3-amine. Pent-1-ene 3-amine, that is going to be the correct name. And next come the cases, students, compounds having 2 or more functional groups. In this case, how to give the numbering? Like we have to follow the same logic, like based on the priority order. C double bond H, CN, which is given the highest priority. CN, C double bond H. What is the name of this compound? CHO, CN. Like it is C double bond H, C triple bond N. C triple bond N carbon is the highest priority, 1, 2. What is the name now going to be? If one carbon, like if you look at this particular carbon, that is the carbon of the principal functional group itself. Other carbon is the carbon of C double bond H, that is, it is a substituent now. So what should be the name now going to be? So this is the principal functional group, this is substituent. So what if CHO is taken as substituent? What is the prefix going to be for CHO? Oxo or formyl? Write down one logical point here. Okay. CHO prefix. Okay. If oxo or formyl, these are the 2 cases for CHO. Oxo is used when carbon of CHO, is included in parent carbon chain, that is PCC. we are going to use the prefix oxo for CHO whenever the carbon of CHO is included in the parent carbon chain. It is used when carbon of CHO is not included in PCC. Formyl is used whenever the carbon of CHO is not used or not included in the parent carbon chain. Oxo is used whenever the carbon of CHO is included in the parent carbon chain. So in this case, CHO C triple bond N. So I have to use the oxo or formyl. The carbon of C double bond. So what is the name now going to be? I have given everything. So how many carbons are there? Yeah, how many carbons are there? 2 carbons. This is root word. Eth. Carbon single bond. So plus N. Yes or no? What is going to be the secondary suffix? C triple bond N. That's the principal bond. Nitrile.
Nitrile.
Primary prefix no cyclo, so no primary prefix. Secondary prefix
Oxo.
oxo. At what position? Second position. So 2 oxo ethane nitrile. Okay, 2 oxo ethane nitrile. That is going to be the correct name. NH2 C double bond NH2. What is the name of this compound? NH2 C double bond NH2. What is the name of this compound? CH3 C double bond NH2. We have already named this. 1, 2, CH3 C double bond NH2. What is the name of this?
Ethanamide.
Namide.
Ethanamide, right? Now let us make the change. HC double bond NH2. HC double bond NH2.
Methanamide.
Methanamide. Now what I am doing? I am replacing H with NH2. So it is methanamide only, but since hydrogen is replaced with NH2, this NH2 is now taken as substituent. The C double bond NH2 is the principal functional group. So can I say only one carbon? So substituent has to be on that carbon only. So amino, whenever NH2 is the substituent, you have to use amino methanamide. Can I write like this or not?
Yes.
Yes or no? So amino methanamide, that is going to name. It is also called as urea. Try to name this CH3 CHOH CH2 C double bond of Cl. CH3 CHOH CH2 C double bond of Cl. So 1, 2, 3, 4. 4 carbons are there in the long chain. On the first carbon, first priority has been given to C double bond of Cl when compared to H. That is normal based on priority order. Since first lowest number is given to this one, so on the third you have hydroxy. So 3 hydroxy, 1, 2, 3, 4 butane, butan oil chloride. 3 hydroxy butan oil chloride. 3 hydroxy butan oil chloride. That is going to be the right name because C double bond of Cl, that is going to be nothing but your oil halide. So oil chloride here is there, and it is just 4 carbons. So butanoyl chloride, and on the third carbon you have hydroxy. So 3 hydroxy butanoyl chloride. Is that clear, students? Is everything clear?
Yes, sir.
Yes.
COH. What is the name? Ethane 1,2 dioic acid. This is the name, same name which we have discussed. Or ethane dioic acid or oxalic acid. Oxalic acid is a common name. Ethane 1,2 dioic acid, that is the IUPAC name. Next note. If carbon containing functional group is treated as substituent, then its carbon is not included in PCC except aldehyde and ketone. Understand this point carefully. If a carbon containing functional group is treated as substituent, if you are treating carbon containing functional group as a substituent, then its carbon is not included in the parent carbon chain except for aldehydes and ketones. Based on this logic, you try to name few compounds. COH, CH2, 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 C double bond O, Cl. Now try to name this compound. All of you give the name of this compound. Right or wrong, it's okay. You try to, you have to try first. Okay, whether you're getting right answer or wrong answer, that is a different scenario. First, you have to give your attempt. Not only the IUPAC nomenclatures, everything. Whatever the concept you feel difficult or easy, obviously all concepts will not be easy and will not be difficult. There are some concepts which you feel easy. There are some concepts which you might be feeling a lot improvement can be done. So how effectively you are performing and how effectively you are solving, how many problems you are solving, all these count in the final exam. Right? What is the name of this compound, students? C double bond OH, CH2, 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 C double bond Cl. How I have to give the numbering? Obviously, C double bond OH is the highest priority. So 1, 2, 3, 4, 5, 6. Can I write like this?
So from blue, we start the number.
Yes, I can. I cannot include the sixth one. That's what I'm saying. Because the carbon, if carbon containing functional group is stated as substituent, this C double bond Cl is a substituent now. Yes or no? Haloformyl. Whenever you use C double bond Cl as substituent, use the prefix haloformyl. So we can say on the fifth position you have chloroformyl or chlorocarbamyl. On the first position you have oic acid. So what I can say, students, now 5-chlorocarbamyl pentan-1-oic acid. Yes or no? 5-chlorocarbamyl, because everywhere you have carbon-carbon single bond, so pentan-1-oic acid. 1, 2, 3, 4, 5 numbering has to be given, and you should not include the carbon of C double bond of Cl because it is treated as substituent now, and only that can be done only if it is parent. If it is aldehyde or ketone, then only you should include the carbon in the parent carbon chains. So 5-chlorocarbonyl or 5-chloroformyl pentanoic acid. What is the name of this? Like we have COH and C double bond O. The C bond is a carbon containing functional group, but is an exceptional gate. We have to include that carbon in the parent carbon chain. So 1, 2, 3, 4. So 1, 2, 3, 4 means you are going to have third carbon, you have C double bond O. So 3-oxo butanoic acid. 3-oxo butanoic acid. Right. Next compound. C double bond NH2, CH2, CH2, CN. When compared to C double bond NH2 and CN, which is given the highest priority? Amides or cyanides?
Cyanides.
Amides are given the highest priority. If you look at the priority order, so cyanides have to be taken as substituents. So 1, 2, 3. If cyanide, this is a carbon containing functional group, but it is stated as substituent now. So I cannot include this carbon in the parent carbon chain. So on the third position you have cyano. So 3-cyanopropanamide. 3-cyanopropanamide, that is going to be name. I am writing 3-cyano. I am not including the carbon of CN in the parent carbon chain. Right. Note, next point. If CHO group is treated as substituent, then if carbon of CHO is included in the parent carbon chain, then oxo prefix is used. If carbon of CHO is not included, this is the same rule I have told you earlier. If you remember, I have written some rule here. Yes or no? CHO, you can use prefixes oxo or formyl. When you have to use oxo, when carbon of CHO is included in the parent carbon chain. If it is used when carbon of CHO is not included in parent carbon chain, then you have to use formyl. Try to solve this example. C double bond OH, CH2, CH2, C double bond OH. All of you try to solve this question. C double bond OH, CH2, CH2, C double bond OH.
4-oxobutanoic acid.
4-oxobutanoic acid. 1, 2, 3, 4. This carbon of C double bond is included in the parent carbon chain. So 4-oxobutanoic acid. Next compound, C double bond OH, CH2, CHO. Do I need to consider the long chain in this fashion? 1, 2, 3, 4. Or I need to consider long chain in this fashion. This first
Maximum
one, second one.
carbon.
5 carbons you take because CHO is just a substituent now. Yes or no? CHO is just taken a substituent now. So I have to include 1, 2, 3, 4, 5. 5 carbons as long chain. If it is 5 carbon long chain, the CHO is substituent, just substituents. So on the third position you have formyl. Numbering has to be given in this direction. 1, 2, 3, 4, 5. Third position you have formyl now because the carbon of CHO is not included in the functional group, not including the parent carbon chain. It is just present as substituents. So third position you have formyl, fourth position you have methyl. F comes first before M based on alphabetical order. So 3 formyl, 4 methyl, pentanoic acid, right? 3 formyl, 4 methyl, pentanoic acid. That's the right name. Try to solve for this. The same compound which has been given earlier. If you think 1, 2, 3, 3-cyanopropanamide. 3-cyanopropanamide is going to be the name for this particular compound. Right, students? Then we are going to look at the names of ethers. Like what is the naming of ethers? Like how the IUPAC name? Alkoxy alkanes, ROR systems, alkoxy alkanes, CH3OCH3. What is the name of this? CH3OCH3. It is nothing but methoxymethane. CH3OCH2CH3. Methoxyethane, because OCH3 have to consider ethane, the long chain. The more number of carbon atoms will be in the root word. Methoxyethane. CH3OCH3CH3. What is the name here? Like we have to give the numbering. This is a long chain, 1, 2, 3 carbons, 1, 2, 3 carbons. On the second position you have OCH3. On the second position you have methoxy. So 2 methoxy propane. 2 methoxy propane. Yes or no? 3 carbons are the long chain. So propane. So 3 methoxy propane. That is going to be the correct number. Right. Ester. What is the name you are going to use for esters? O8. Suffix is going to be O8. Special suffix is carboxylate. Prefix is alkyl carbonyl or carbalcoxy. RC double bond O. OR. So these are the suffix, special suffix and prefixes. RC double bond O. OR. This is alkyl group and this is alkanoid group. Alkyl alkanoids. They are said to be alkyl alkanoids. Try to name this compound. CH3 C double bond O. OCH3. 2 carbons are there. So ethanoate and 1 methyl. So methyl ethanoate. Methyl ethanoate is going to be the correct name for this particular compound. Is that clear or not? Alkyl alkanoids. So more number of carbon atoms wherever you have, there you have to treat the alkanoid groups. So methyl, like a R C double bond O group. This is said to be alkanoid group. OR is the alkyl group. Try to name this HC double bond OCH3. HC double bond OCH3. What is the name of this particular compound?
Methyl methyl.
This is alkyl group. This is alkanoid group. So methyl methanoate. Methyl methanoate. That is going to be the correct name. CH3 CHBr C double bond OCH3. What is the name here? This is alkyl group. This is alkanoid group. So alkyl alkanoid. Alkyl means methyl. Methyl comes first. Alkanoid. In the alkanoid we have a substitution. So 2 bromo propanoid. Okay. Methyl. This is alkyl group. This is alkyl group. R O C double bond O R dash. This is alkyl. This is alkanoid. Right. So methyl 2 bromo propanoid, that is going to be the correct name. Methyl 2 bromo propanoid. Now naming of secondary and tertiary amines. If you look at the common system, there we will use the same name amine. But whenever we have secondary and tertiary amines, in that case you are going to write n ethyl, n methyl, n comma n dialkyl. So that is going to be introduced. So like CH3, CH2, CH2, NH, CH3. What you are going to use here? CH3, CH2, CH2, NH, CH3 means if it is just a CH3, CH2, what is the name of this compound? CH3, CH2, CH2, NH2. It is nothing but propanamine, propan 1-amine. But what change we have done here? On the nitrogen, whatever we have NH2, that hydrogen has been replaced by a methyl group. So N methyl propan 1-amine. Okay, because NH2, the hydrogen of nitrogen, out of two hydrogens, one of the hydrogen has been replaced by a methyl group. So N methyl propan 1-amine, that is going to be the correct name for this particular compound. N methyl propan 1-amine. Whatever the name of this compound, CH3, CH2, CH, CH3, NH, CH2, CH3. All of you give the names of students, names of these compounds.
N-ethyl butene 2-amine.
N-ethyl butane 2-amine. Like this is a carbon chain 1, 2, 3, 4. On the second position, you have NHC2H5. So N-ethyl butane 2-amine, right? This compound, try to name this.
N-dimethyl ethanamine.
So we have to give numbering. So 1, 2, 2 carbons in long chain. So N, N dimethyl ethanamine. Like if you have CH3, CH2, NH2, then it is said to be ethanamine. But now the nitrogen, two hydrogens of nitrogen, they have replaced with the methyl groups. So N, N dimethyl ethanamine, that is the right name. Very good. Carboxylic acid anhydride, we are going to have this type of name. Oic anhydride, the suffix, special suffix is carboxylic anhydride. So let us look at the name. So how the anhydride is formed? Formation of anhydride. Look at this carefully. RC double bond OH plus RC double bond OH. Oic acid. That when you treat with H plus in the presence of heating, what is going to happen, students? When you treat that in the presence of H plus, and if you heat it, you will be getting oic anhydride. If you look at the mechanistic approach of this reaction, to try to understand RC double bond OH, we are treating this with H plus. Like two molecules are there. One of the molecules is treated with H plus. What is going to happen? The lone pair of electrons and oxygen, they are going to be attacking the H plus ion. As soon as they attack the H plus ion, you will be getting RC double bond O. Earlier, this oxygen has how many lone pairs?
2.
Now, one of the lone pair is using the new attack. So now oxygen has only one lone pair, and the attack is with the H plus. H plus has positive charge earlier. Now the lone pair of electrons on oxygen has been donated to H plus. That means shared between oxygen and hydrogen. So the positive charge on hydrogen has to be nullified. Oxygen will now generate a positive charge. RC double bond O. Oxygen has one lone pair, positive charge and OH bond, and we have COH group. Now we have another molecule. What is the other molecule? Other molecule also same. RC double bond OH. The other molecule is RC double bond OH. So what happens now is the lone pair of electrons and oxygen from the other molecule of carboxylic acid, they are actually going to be attacking this particular carbon, and the carbon double bond oxygen, the pi electron density which was present here, that is going to be moving towards oxygen to nullify the positive charge. So what is the total role of H plus here? The role of H plus is actually to increase the electrophilic nature of this particular carbon. Yes or no? The carbon, if we just take 2 moles of carboxylic acid, the attack is not going to be happening. The lone pair of electrons will not attack easily because the carbon is not electrophilic in nature. If you take H plus ion, the electrophilicity of the carbon has been increased. Why? Because the lone pair of electrons and oxygen attack H plus. Why? Because H plus is positively charged. Lone pair of electrons and oxygen are not involved in any bonding. Because of that, oxygen developed positive charge. Because oxygen developed positive charge, the pi electron density will be moving towards oxygen, which is electronegative atom, and bearing a positive charge is not stable. So what happens in this course? So we get RC the carbon and oxygen will now have a single bond, as the pi electron density has to be donated to oxygen or given to oxygen. OH bond is as it is now. This carbon also has OH bond. This carbon also has OH bond. And you have the carbon connected with oxygen. Oxygen has only one lone pair now. This oxygen, concentrate on this oxygen. Earlier, this oxygen has two lone pairs. Now it will have only one lone pair and a positive charge and OH bond. And you have C double bond O R. Can I say lone pair of electrons on this oxygen? They are going to be attacking this particular proton? Yes, for sure. Generating R C OH OH2 plus. Why it is so? Because to neutralize the positively charged oxygen, we get O now, oxygen regain its lone pair, and we get C double bond to R dash. Ultimately, lone pair of electrons on oxygen comes into generating what? R C double bond O. One lone pair is there, positive charge OH bond. As soon as this comes into the CO bond is going to be cleaved, loss of H2 occurs. C double bond to R dash. This will ultimately give the compound like R C double bond O C double bond R dash upon loss of H plus. This is the mechanistic approach. You don't worry with the mechanism as of now, because we have not started with the real organic chemistry. It is just the IUPAC nomenclature. So based on the functional groups, based on the carboxylic acid from which we are getting the carboxylic anhydride, the naming has to be done. So these are the oic acid, carboxylic acid. These are the oic anhydride. And if you look at heating, why heating is required? Because it involves the bond cleavages. Bond cleavages are involved, so we require high temperature. Why H plus is required? To increase the electrophility of the reaction. And this reaction is actually reversible in nature. Okay. So naming of anhydride is derived from the name of carboxylic acid from which it is synthesized. That is why we have written the carboxylic acid also. So we are going to look at the names of anhydrates and special molecules in next class. Then we are going to continue with isomerism. Fine. Thank you all, everyone. Bye.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.